So here are some worked out solutions for Unit 1, Worksheet 2, Math 3. So I'm going to start with question number 3. So I want to graph number 3. So in order to graph number 3, I need to put it in standard form. So what that means is here 1 is being subtracted from x, but 4 is not, right? If 4 were with the x, it would be up in the power. So that means 4 belongs to h of x, and remember that's the same as y. So I'm going to move the 4 over to the y, so I'm going to subtract 4. So then when I do that, I have it now in my standard form. So I want to find my start point. So my start point. So I look to see how x is being adjusted. So I go to my x term first, and so minus 1, so I need to undo that, readjust it, so that means it's going to be positive 1. Right, because if I put 1 in, 1 minus 1 is 0. So this will be 1, and then do the same thing for y. So y needs to be 4, right, to zero it out. So my start point is positive 1, positive 4. So I'm going to go over 1 and then up 4. So now this is exponential. How do I know this graph is exponential? Because the variable is in the power. So that means the basic graph, I have an asymptote first, and then I have a graph that does that, and I need 2 points. So I do my asymptote first, so my start point, 1, 4, gives me my asymptote. Then I'm going to use my stretch, which is 2. So from here, I'm going to go up 2 over 1. So up 2 over 1. And then my second point is always 1 above. And that's because when x is 1, I would get 2 to the 0, which is 1. So I need to go up 1. And there is my graph. And now for domain and range. So the domain is left to right. So I'm going to look at my arrow. So I have an arrow here. This arrow means forever to the left, so that would be negative infinity. Does not mean forever down, because the asymptote keeps me from going forever down. So my asymptote is at 1, 2, 3, 4. So that means I do not go below 4. Look for my other arrow here. Means I'm going up forever. And then it also is pulling me to the right, because it's not going straight up. It might look like it, but it's also pulling to the right, so forever to the right. So then my domain in interval notation, so left to right. So negative infinity to positive infinity. And then from bottom to top for range, bottom to top, so my y value, so bottom value is 4, and top value is positive infinity, can never equal infinity. It's hitting an asymptote at 4, so it cannot equal 4. Okay. And then let's take a look at number 8. So the minus 2, I have to decide, is it with the x, or is it supposed to be over here with the g of x or y? And it is not grouped with the x, right, or inside the squared term, so that means it doesn't belong to the x. It's not shifting the x, so it should be over with the y. So that means I need to add 2 to both sides, so that'll be just y plus 2. And then it cancels here. So negative 3x squared. So how do I know if something's with the x? So if it was with the x, it would be like up in the power here, like x plus 2. Or it would be grouped, like in the absolute value, or grouped like in the parentheses right here, right? So if it's in parentheses, if it's in the absolute value, if it's up in the power. So if it's just off to the side like that, it's not with the x, it's with the squares, so it needs to move over to the y. So for my start point, Am I adding or subtracting anything to x? No, so that would be 0. And then I'm adjusting my y value. I'm adding 2. So to 0 it back, my y needs to be negative 2. So my start is at 0, negative 2. And this is a squared, right? Power of 2, x squared. So that means it's going to be a parabola. So this is my vertex. So 0, negative 2 is also called my vertex. And then my stretch is the number multiplying my x squared term. So my stretch is negative 3. So I'm going to go down 3 and over 1. And then I'm going to reflect it to the other side so it's curved, right? So I'm going to reflect it over to get the left side. So down 3 and over 1. And then domain and range. So I'm going to check out my arrows first. So I have this arrow here, definitely pointing me down, so that's to negative infinity, and also drawing me to the left, right? It's not going straight down. It might look like it, but it's also drawing me to the left, so that would be negative infinity. Now check out this arrow. So it's drawing me down, already got it, and it's drawing me to the right, right? Because it's not going straight, but pulling to the right, so to the right would be positive. And I have no arrow drawing me up, right? There's no arrow pointed up or uppish. So that means there has to be a highest point, and the highest point is here at my vertex, which is at negative 2. Right? 1, 2. Okay, so now I can do my domain and range. So left to right cannot equal infinities. Bottom to top. So bottom to top cannot equal infinities, but it can equal negative 2, the vertex. And there's my domain and range.